Homework 12, Polynomial Division, Factor Theorem, Rational Zero Theorem, video number 1. In the previous series of videos, we talked about graphing polynomial functions by determining the end behavior, both ends rising, both ends falling, right rising, left falling, or left rising and right falling. We talked about the number of turns a graph can make, which was its degree minus 1. We talked about finding the y-intercepts and finding the x-intercepts, their multiplicities, and what that said about whether the graph crossed the x-axis or touched the x-axis and turned around. But the problem with finding the x-intercepts is that we had to solve a function equal to 0. And if the function was already factored, we were okay. We could just set each factor equal to 0. But if the function wasn't factored, then we had to rely on some factoring techniques or possibly using the quadratic formula. However, there are things that don't factor nicely using the techniques that you may have learned already. So what we're going to explore in this section is a way to factor any polynomial using one technique. Now, just like the quadratic formula, any technique that is universal is also cumbersome and has a lot of steps to it. So as we start building this technique for factoring anything, keep that in mind, that sometimes there are easier ways to factor some polynomials, but there's only one technique that works universally, and we're about to see it. But in order to get to it, we have to get through polynomial division. Because think about it, if you're factoring something, you're turning it back into a multiplication problem. You are unmultiplying it. Well, isn't unmultiplying just the same as dividing? So if we're going to use division as it means for factoring, we need to know how to divide. And there are two types of division we're going to look at. One of them is called long division, and this is where most people go, oh, I hate that. But I promise you, it's not as bad as it seems, especially if you remember how to do long division numerically. Let's take a look at this first example where we're attempting to divide this trinomial, 10x squared plus 3x minus 3, by this binomial, 2x minus 2. You can do any polynomial division problem as a long division problem. The first part that goes inside is called the dividend, and it goes inside what I call the division house. 10x squared plus 3x minus 3. The part you divide by is called the divisor, and it goes on the outside to the left. And the trick to doing polynomial long division is to just mirror the same moves that you would do in numerical long division, just making slight adjustments as necessary. So to go through this first example, I'm going to contrast it to a similar but not quite the same problem. We're going to divide something by 21, and the thing we're going to divide by 21 is 1033. Now be careful, all I did was steal all the coefficients from this problem and put them into that one. It doesn't mean that you can just do that to get the answer to this. It's simply to compare steps. So let's start over here with the numerical division problem. If I said to divide this by hand, do you remember what the first move is? The first move is to ask how many times the divisor goes into part of the dividend. The first part that's large enough to contain more than one of these. Like 10 doesn't contain any 21s. But if I stretch it out to 103, then I can ask how many times does 21 go into 103. So the first question over here, how many times does 21 go into 103? Let's go ahead and answer that question. I'll tell you right now the answer is 4. 5 is too many. If you did 5 times 21, you would get 105. So let's just pretend that you knew the answer was 4. For polynomial long division, you kind of start the exact same way, with one big difference. Instead of looking at both polynomials as a whole, you only look at their leading terms. The leading term on the divisor is 2x. The leading term on the dividend is 10x squared. But you still ask yourself the equivalent question, how many times does 2x go into, move that over, 10x squared? So it's the exact same question. But the way you go about answering is a little bit different. Because answering this question is not intuitive. This one, yeah. If I have $103, how many times can I make $21 out of that? 4 with some left over. But I can't use the same analogy here. However, there is a straightforward way to answer this question because all you're asking is a division problem, aka a fraction. So to answer this question, I would put the leading term of the dividend, the 10x squared, over the leading term of the divisor, 2x. And that's just a fraction that you can reduce. You're really dividing, but if you think about it as reducing, it seems to be a little easier. 10 divided by 2 is 5. And when you have one power on top of another, you subtract. So 2 minus 1 is 1. It's x to the first power, or just x. So the answer to how many times does 2x go into 10x squared is 5x. And you can check that by multiplying these. 2 times 5 is 10, x times x is x squared. And that's going to be the first term I write on the top. Now, it's not consistent whether you write it on top of the like term or you write it on top of the term that you divide it into. I'm going to try to always write it over the like term below it. But it's the same first move, just in a slightly more theoretical context with a more definitive approach to evaluating it. And let's say you get past the first move. What is your second move in the numerical? Sorry, I dropped a marker. In the numerical problem. Well, once you figured out that 21 goes into 103 4 times, the next thing you do is multiply that 4 times 21. So in other words, you multiply this number times that number and write it underneath the dividend. 4 times 21 is 84. Let's line it up under the 103. Over here, you do the exact same move. You multiply the term you just wrote on the top and the quotient, which is 5x, and you multiply it times the divisor. But when you multiply it times the divisor, it's not just by the leading term, it's by all of it. So we're going to multiply 5x by 2x minus 1. And just like over here, we're going to write the product underneath the dividend. So this is just a little bit of distributive property. 5x times 2x is 10x squared. Line up your like terms. 5x times negative 1 is negative 5x. Line up your like terms. So it's the exact same move as over there. Whatever was on top gets multiplied by the divisor and gets written underneath the dividend. So what's the next move over here? Subtract. So we're going to do 104 minus 83, which I believe is 19. Guess what the next move over here is? Subtract. But I'm going to add a word to it. Subtract carefully. And here's what I mean by carefully. When we subtracted the 84 over here, we just put one minus on there. Subtracted the whole 84. But if I put a minus sign here, I am not subtracting the entire product. I'm only subtracting the first term. So how do I subtract the entire product? By putting parentheses around the entire product before I write the minus sign. But now that brings up another issue. I've got parentheses around these guys, and I don't need them there because I need to combine some like terms. Well, that's easy to do. I've got a negative in front of parentheses, so I can just distribute it. The 10x squared becomes negative, but the 5x becomes positive. So when I say subtract carefully, what I could say is change signs and combine. It's really just subtracting everything at one time. And when you subtract everything, everybody's signs change. What should happen is the leading term should cancel. If you retrace your steps, what you were basically doing was building a matching term here, so that when you subtract, they cancel. If these don't cancel, something went wrong, go back and fix it. Over here, when we combine the plus 8x and the plus 5x, the plus 3x and the plus 5x, it gives us plus 8x. My mind was ahead of myself. So it's the same move over here, subtract. Just do it carefully by changing signs and combining. Let's go back over here. What's our fourth move? Bring down the 3. More specifically, bring down the next digit in the dividend. Bring down the 3. So guess what the next move over here is? Bring down the minus 3. More specifically, bring down the next term in the dividend. We'll just say bring down the -3. And then over there with the numbers, we just do it again. And that's what we'll do over here. So we'll just say number 5, repeat. So let's finish off the numerical problem. 21 goes into 93, I believe it goes into 93 9 times. We'll check in a minute. As soon as we multiply, I'll know. 9 times 21 is 189. And then subtract. Looks like we're going to get a remainder of 4. Over here, same thing. Just carefully. Move that -3 over where it belongs. All right, and remember, when you play the game over here, when you ask the question, how many times does something go into something, you only focus on leading terms. So how many times does 2x go into positive 8x? Well, we don't have to answer that as a division problem. We can just write 8x on top of 2x and see what happens. The x's cancel. 8 divided by 2 is 4. And more specifically, positive 8 divided by 2 is positive 4. So that's the next term in the quotient. Then multiply 4 times the entire divisor and write it below the dividend. So 4 times 2x, 4 times 2x is 8x. 4 times -1 is -4. And here comes the move where most mistakes are made. Subtract everything simultaneously. To do that, change the signs so the 8 becomes negative, but the 4 becomes positive. And notice that I blatantly crossed out the minus signs so that you would know I made a change. If I had a minus sign and I changed it to a plus like that and then somebody interrupted me, and then I came back and tried to remember where I was, am I looking at this and saying, is that a minus I already turned into a plus? Or is it a plus that I haven't turned into a minus yet? By crossing out the minus sign and writing a plus above it, there's no debate that you've already made that change. And combine like terms. The 8x's cancel, that was designed to happen. -3 and positive 4 is positive 1. So the steps for polynomial long division are the exact same as the steps for numerical long division. You just have to make adjustments to compensate for the fact that you're dealing with variables. Now we're not quite over it yet, not quite done yet, because we got to talk about what to do with the remainder, if there is one. If the remainder was 0, it would be over. The answer would be 49. But the remainder is 4. Now what can we do to represent the remainder in the solution? Well, if it's a number problem, we can put a decimal, throw on zeros, and keep going. Not an option over here. We could put R4, but that's kind of lazy. So what we're going to do is append the remainder onto the quotient by making it a fraction on top of the divisor. In other words, 49 and 4/21. Now we're going to do the same thing over here, just a little bit different. We are going to put the remainder on top of the divisor and literally add it on to the answer. Kind of got crowded there, but our answer to this long division problem is 5x plus 4 plus a remainder of 1 over 2x minus 1. And in the homework, that's how they're going to prompt you for the answers. And some of the questions, they have an empty box here for the quotient and an empty box there for the remainder, and you just have to type them in. We'll do another example of long division because I think it needs it.